The conference room in Brussels fell silent as the NATO intelligence officer placed the photographs on the table. Grainy surveillance images showed something that made even the most battle-hardened generals shift uncomfortably in their chairs. An endless column of Soviet T-62 tanks stretching beyond the horizon, their steel hulls gleaming. Under the grey Eastern European sky, the date stamped on the images told a story more terrifying than any thriller. This was happening now, just beyond the Iron Curtain, where thousands of armored vehicles sat waiting like coiled serpents. One American colonel traced his finger along the convoy route and whispered what everyone was thinking. If those tanks rolled west, conventional weapons wouldn't stop them in time. The numerical advantage was crushing, 3 Soviet tanks for every NATO defender, and the math of warfare was brutally simple. Something had to change, or the balance of power would shatter like glass under a hammer's blow. This moment, frozen in classified briefing rooms, across Western Europe, would birth a legend whispered in 2 languages, salvation in English and something far darker in Russian. The weapon that emerged from this desperation would rewrite the rules of armored combat forever. Engineers called it a technological marvel, a rotating cannon that could spit death at rates previously thought impossible, each round capable of punching through steel plates designed to withstand anything in the Western arsenal. But statistics and technical specifications couldn't capture what it truly represented. A response to an existential nightmare that kept defense ministers awake at night. The Soviets had numbers, they had production capacity, and their tank columns grew longer with each passing month, while NATO scrambled to find an answer. In underground bunkers and classified facilities, teams worked around the clock, driven by a single terrifying question. What happens when quantity has a quality all its own? The Cold War had always been fought with calculations and deterrence, but those Soviet tanks weren't theoretical anymore. They were real, they were waiting, and time was running out to find something that could level a battlefield tilted dangerously toward catastrophe. The maps told a story that no amount of political rhetoric could soften. In the operations room beneath NATO headquarters, analysts had spent months tracking Soviet armor deployments along the inner German border, watching with growing alarm as divisions multiplied in the flatlands of East Germany and Czechoslovakia. Every reconnaissance flight brought back images that added another layer to the nightmare. Tank parks sprawling across former farmland, railway stations choked with flatbed cars carrying fresh armor westward, maintenance depots operating at capacity that suggested something beyond routine rotation. The officers studying these reports didn't need advanced degrees to understand the implications. The Fulda Gap, that crucial corridor through the German highlands, had become a funnel pointed directly at the heart of Western Europe, and massed on the other side waited an armored force larger than anything seen since the Second World War ended. The numbers haunted every strategic calculation. 300 Soviet tanks could punch through before NATO could mobilize effective resistance, and intelligence suggested they had 3 times that number within striking distance. Field commanders stationed along the border lived with this reality every single day, watching through binoculars as Soviet forces conducted exercises that looked disturbingly like invasion rehearsals. A British tank captain stationed near the border checkpoint later recalled the sinking feeling when his entire squadron realized they were facing a Soviet regiment, his 14 tanks against their 94, positioned in terrain that favored the attacker. The doctrine manuals promised reinforcements and tactical advantages, but those promises felt hollow when you counted the actual armor available versus what satellite imagery showed, gathering in staging areas across the divide. NATO's conventional forces were spread thin across thousands of miles, while Soviet planners had concentrated overwhelming strength at key penetration points, turning military strategy into a brutal mathematics problem where Western forces always came up short. Sleep became difficult for the officers, who understood just how quickly those numbers could translate into catastrophe. The political leadership demanded solutions that military planners struggled to provide without resorting to nuclear escalation. In war game simulations run throughout the late 1960s, every conventional scenario ended the same way. Soviet armor breaking through defensive lines within days, their numerical superiority overwhelming NATO positions before reserves could arrive from across the Atlantic. The theorists spoke about force multipliers and technological advantages. But what did that mean against a doctrine built on mass and momentum? Defense ministers returned from classified briefings with haunted expressions, knowing they couldn't publicly acknowledge how precarious the balance had become. The deterrence strategy that had kept peace for 2 decades suddenly looked fragile, dependent on threats that everyone hoped would never be tested, because testing them meant either surrender or apocalypse. Something radical had to emerge from this strategic paralysis, some innovation that could shift calculations away from simple numerical superiority. The answer wouldn't come from traditional thinking or incremental improvements to existing systems. What NATO needed was a weapon so devastatingly effective against armored vehicles that it could neutralize the Soviet advantage through sheer destructive capability. Something that would make tank commanders hesitate before rolling westward, knowing their steel fortresses had become vulnerable in ways that no additional armor plating could prevent. The telegram arrived at Aberdeen Proving Ground on a Tuesday morning in late 1968, marked with classification stamps that guaranteed the courier's hand trembled slightly when delivering it to the research director's office. Inside, the language was bureaucratic, but the message screamed urgency. Proceed immediately with high-velocity rotary cannon development, all funding restrictions lifted, timeline compressed to operational prototype within 36 months. Dr. Richard Feldman read it twice before reaching for his telephone, already calculating which engineers he'd need to pull from existing projects, knowing that somewhere in a sealed briefing room, generals had decided conventional weapons weren't cutting through Soviet armor fast enough. The Cold War had always been about incremental advantages, small technological edges that justified enormous budgets. But this directive felt different, heavier, like someone had run the war game simulations one too many times and didn't like how the story ended. Within weeks, a nondescript industrial facility in Vermont became the birthplace of something unprecedented, its windows covered, its parking lot monitored, its staff sworn to secrecy under penalties that made civilian researchers understand they were now part of military operations. The concept seemed almost absurdly simple on the briefing boards. Take the proven Gatling principle, scale it to devastating proportions, and engineer it to fire armor-penetrating rounds at a rate that would saturate a target before tank crews could react. But translating that concept into functioning hardware meant solving problems that kept engineers working through nights, fueled by coffee and Cold War anxiety. Testing barrel configurations that could withstand temperatures hot enough to warp steel, designing feed mechanisms that wouldn't jam when cycling through thousands of rounds per minute. The pressure was relentless because everyone knew Soviet factories weren't idle. Intelligence reports confirmed new tank models arriving monthly, each one potentially rendering current anti-armor weapons obsolete before they left American production lines. The breakthrough came during a winter test session when the prototype finally achieved sustained fire without catastrophic failure. The sound unlike anything heard on conventional firing ranges, not the rhythmic thump of machine guns, but a continuous roar that seemed to tear the air itself apart. Engineers stood behind protective barriers, watching through reinforced glass as depleted uranium rounds shredded a captured Soviet tank hull. Positioned downrange, the penetration so complete that the armor didn't just breach but disintegrated, metal transformed into molten spray by kinetic energy that defied everything armor designers thought they understood. Someone whispered that Stalin himself couldn't have imagined such destructive capability, and the comment hung in the air like prophecy. because they all understood what they'd created wasn't just a weapon, but a paradigm shift that would force Soviet strategists to recalculate everything they'd built their doctrine around. Word filtered up through military channels with the kind of quiet excitement that defense contractors dream about. Field tests exceeded projections. Reliability metrics surpassed requirements. And most importantly, the weapon could do what NATO desperately needed: stop Soviet tanks in numbers large enough to matter. Production authorization came swiftly, accompanied by classified memos discussing deployment scenarios and strategic positioning, the bureaucratic language barely concealing the relief that finally, after years of watching Soviet armor multiply beyond countable numbers, Western forces would have something that could make Moscow's tank commanders lose sleep the way NATO officers had been losing theirs. The technical specifications existed only in documents stamped with security classifications that guaranteed most military personnel would never read them, but the engineers who understood those numbers spoke about them in reverent tones, usually reserved for theoretical physics breakthroughs that redefined possibility. The GAU-8 Avenger measured nearly 20 feet long and weighed over 600 pounds without ammunition, a rotating assembly of 7 barrels that cycled through firing sequences at rates conventional weapons couldn't approach, 4,200 rounds per minute in testing conditions, though operational doctrine recommended shorter bursts to preserve barrel integrity and ammunition reserves. Each barrel fired independently as it rotated into position. The Gatling principle evolved beyond its 19th century origins into something that transformed kinetic energy into a tactical asset capable of altering battlefield calculations. The ammunition itself represented metallurgical innovation, born from nuclear program expertise, depleted uranium cores dense enough to punch through hardened steel like paper, their mass and velocity generating temperatures at impact that turned armor into liability rather than protection. What made Soviet defense planners lose sleep wasn't just the firing rate or the projectile composition, but the physics of sustained accuracy at that velocity, because conventional wisdom suggested such rapid fire would scatter rounds uselessly across landscapes, wasting ammunition on dirt and air. The Avenger's designers solved that problem through barrel arrangement and recoil compensation systems that channeled destructive force along predictable trajectories, creating impact patterns that didn't spray randomly but concentrated on target zones with mathematical precision. During evaluation trials, observers watched through binoculars as test targets, decommissioned vehicle hulls, arranged to simulate Soviet tank formations, absorbed burst after burst, the sound arriving as continuous thunder that rolled across proving grounds like approaching storms. Engineers calculated that a 2-second burst delivered enough projectiles to saturate a target area completely. Overwhelming reactive armor systems designed to deflect single impacts, the sheer volume of incoming rounds ensuring multiple penetrations before defensive measures could respond. The weapon's appetite for ammunition created logistical challenges that required new thinking about supply chains and combat. Endurance, because 4,000 rounds per minute meant the cannon could theoretically empty its entire ammunition drum in approximately 18 seconds of continuous fire. Designers settled on a combat load of roughly 1,000 rounds, balancing firepower against weight constraints and mission duration requirements, each projectile measuring nearly a foot long and weighing nearly a pound. The drum housing this ammunition formed a massive cylinder that dominated any aircraft design, forcing engineers to build the plane around the weapon rather than mounting the weapon on existing airframes. A philosophical reversal that signaled how seriously Pentagon strategists took the Soviet armor. A threat, Moscow's intelligence services eventually obtained fragments of technical data through methods that remain classified, enough information to recognize they face something qualitatively different from incremental weapons improvements, and those reports filtered through military bureaucracy with escalating alarm because Soviet armor doctrine had no ready answer for this kind of concentrated destruction delivered from aircraft that could operate below their most effective air defense envelopes. The aircraft emerged from design conferences looking like nothing that had ever received military funding, its form dictated entirely by the cannon mounted along its center line like a spine of destructive intent, every aluminum panel and hydraulic system positioned to serve the weapon rather than aerodynamic elegance. Engineers at Fairchild Republic received specifications that read more like constraints than opportunities. Build an airframe that could absorb recoil forces equivalent to a small car being thrown backward. Repeatedly, maintain flight stability while firing a weapon whose vibration could shake apart conventional structures, and accomplish this while carrying enough armor to survive ground fire that would shred faster jets designed for altitude and speed. The result looked brutish and purposeful, twin engines mounted high to avoid debris ingestion. During low-altitude operations, straight wings built for maneuverability rather than speed records, and a cockpit surrounded by titanium bathtub thick enough to stop anti-aircraft rounds that pierced standard aluminum fuselages. Test pilots who first climbed into prototypes found instruments arranged around a targeting system that prioritized one function above all others, putting that cannon on target and keeping it there through the chaos of combat. The recoil problem consumed months of development because firing the Avenger at full capacity generated thrust equivalent to one of the aircraft's engines running in reverse, a force that could stall forward momentum or send the plane into uncontrolled flight if engineers miscalculated compensation systems. Wind tunnel tests and computer models could only approximate real-world conditions, so early trials involved mounting the weapon system on ground platforms that recorded every vibration frequency and structural stress point, while engineers adjusted mounting brackets and dampening systems. When live-fire tests finally moved to aircraft integration, observers watched the prototype shudder with each burst, the entire fuselage absorbing punishment that would have torn wings from less robust designs, smoke and spent casings pouring from the aircraft's belly like mechanical entrails. The cannon protruded from the nose slightly, offset from center line, a deliberate asymmetry that balanced the weapon's rotation against aircraft stability, engineering solutions that seemed inelegant until viewed through the lens of pure function over aesthetic consideration. Pilots selected for early evaluation flights came from ground attack backgrounds rather than fighter squadrons, men accustomed to flying low where Soviet air defenses were thickest, their instincts trained toward survival through terrain masking and rapid target engagement rather than dogfighting maneuvers. They learned to love the aircraft's redundancy systems, dual hydraulics, backup flight controls, engines separated widely enough that battle damage to one wouldn't doom the other, features that signaled designers expected these planes to return with holes punched through non-critical systems. The visibility from that armored cockpit gave pilots sightlines crucial for identifying targets in environments cluttered with smoke and burning vehicles, the aircraft responding to control inputs with deliberate precision rather than twitchy sensitivity, a flying gun platform optimized for the exact mission Soviet tank columns represented. NATO commanders reviewing performance data recognized they finally possessed a tactical answer to numerical inferiority, an aircraft that could operate in conditions where faster jets couldn't function effectively, delivering firepower concentrated enough to achieve strategic objectives despite being outnumbered. The plane received its unofficial name from pilots who appreciated its ungainly appearance and vicious capability, the Warthog, a designation that captured both its aesthetic brutality and its effectiveness in the kind of grinding combat scenarios that European battlefields promised if Soviet tanks ever rolled westward across the inter-German border towards cities they'd been positioned to capture. Intelligence officers in Moscow's GRU headquarters first received fragmentary reports from technical surveillance teams operating near American proving grounds, satellite imagery showing an aircraft configuration that defied conventional design philosophy, its proportions suggesting the fuselage existed merely to carry something extraordinary. The photographs circulated through analytical departments where men trained to assess Western military developments studied the strange twin-engine design with mounting concern, noting the prominent cannon installation that dwarfed any airborne weapon system in Soviet inventories. Within weeks, additional intelligence arrived through human sources. Engineers who'd observed test firings described destruction patterns that seemed exaggerated until multiple independent reports corroborated the same impossible claims about penetration, depth, and firing rates. The data moved upward through military bureaucracy with increasing urgency, each level adding commentary that reflected growing alarm about implications for armored doctrine that had defined Soviet strategic advantage since the Great Patriotic War ended. Technical intelligence analysts constructed performance estimates from the fragmentary evidence, their calculations producing results that senior officers initially rejected as Western disinformation designed to provoke wasteful countermeasure programs. But additional confirmation arrived from sources within NATO military circles, documents describing the weapon's specifications in terminology that matched Soviet engineering assessments, eliminating doubt about the threat's authenticity. Mock-up tests conducted at classified facilities outside Moscow used captured Western armor-piercing technology to approximate the American cannon's effects. Engineers firing at decommissioned tanks to validate penetration claims that had seemed fantastical in initial reports. The results silenced skeptics. Steel plate that should have deflected conventional rounds disintegrated under sustained fire that simulated the American weapon's capability, leaving engineers staring at wreckage that represented obsolescence for armor designs considered cutting-edge mere months earlier. Warsaw-packed military planners convened emergency sessions to assess tactical implications, map tables covered with defensive positions along the inter-German border suddenly appearing vulnerable to an aircraft specifically designed to exploit Soviet armored concentrations. Tank division commanders received classified briefings describing the threat in terms that avoided technical details while emphasizing lethality. An American aircraft that could destroy multiple vehicles during single attack runs, operating at altitudes where traditional air defenses struggled to acquire targets effectively. The psychological impact rippled through officer ranks faster than official communications. Whispered conversations in military academies and forward bases, spreading awareness that Western forces had developed something that threatened to neutralize numerical superiority through technological asymmetry. Countermeasure programs initiated in response consumed resources and attention across Soviet military research establishments, engineers tasked with developing reactive armor upgrades and formation tactics that might reduce casualties from an aircraft most had never seen but already feared. The weapon's reputation grew through absence of direct confrontation, its existence forcing doctrinal changes that acknowledged a fundamental shift in armored warfare's calculus. Western desperation had produced innovation that Soviet military planners privately admitted represented their most serious tactical concern since nuclear weapons had first destabilized strategic assumptions decades earlier. The first A-10 squadrons arrived at forward bases in West Germany under conditions of operational secrecy that fooled no one, their distinctive silhouettes visible to Soviet observation posts across the fortified border. as ground crews prepared hardened shelters designed for rapid scramble launches. American pilots selected for the initial deployments underwent psychological screening alongside tactical training, commanders needing aviators who could maintain effectiveness while flying low enough to see individual tank commanders through their cupolas, close enough that return fire became personal rather than abstract. The aircraft sat on alert status within minutes of Soviet armor concentrations, their presence announced through deliberate intelligence leaks that ensured Warsaw Pact commanders understood exactly what waited beyond the boundary markers and minefields. German villagers living near the bases grew accustomed to the sound of engines cycling through pre-flight checks at irregular hours. Practice runs that sent the angular aircraft screaming over farmland at altitudes that rattled windows and startled livestock. Each pass a demonstration meant for audiences on both sides of the divide. Soviet tank crews stationed in East Germany received updated tactical briefings that included grainy photographs of the American aircraft, instructors pointing to the nose-mounted cannon while explaining attack profiles with clinical detachment that failed to mask the weapon's implications for crew survival. Officers described the sound as distinctive, a mechanical roar unlike conventional aircraft weapons, telling their men that hearing it meant the attack had already begun, and evasive maneuvers offered the only hope for avoiding destruction, measured in seconds rather than minutes. The psychological burden settled over armored units like winter fog, experienced tankers, who dismissed previous Western aircraft as manageable threats, now conducting vehicle inspections with new urgency, checking reactive armor installations, and discussing dispersion tactics during off-duty hours. Some crews began calling it the Devil's Buzzsaw in conversations they thought officers couldn't hear, the nickname spreading through barracks and maintenance facilities until even commanders used the term in informal contexts, acknowledging fear that official doctrine pretended didn't exist. Forward operating procedures changed throughout NATO air wings as pilots accumulated flight hours in the weapons system, developing attack patterns optimized for Central European terrain, where Soviet armor would concentrate during any westward offensive. Training missions simulated combat conditions with intensity that occasionally crossed into recklessness. Young aviators pushing altitude limits and firing angles while trying to master an aircraft that handled like a truck but killed like a scalpel when properly employed. The cannon's presence became psychological ammunition before any shots were fired in anger, its reputation preceding actual combat effectiveness through intelligence channels that ensured Soviet military planners lost sleep over capabilities they couldn't directly counter. Maintenance crews painted kill markings on practice aircraft as dark humor, shark's teeth around cannon barrels that suggested appetites these machines might never satisfy if deterrence held, but stood ready to feed should diplomacy fail. The deployment achieved its strategic purpose through sheer existence, NATO commanders recognizing that uncertainty about the weapon's true effectiveness served deterrence better than any demonstration could, letting Soviet imagination fill gaps in their intelligence with nightmares more terrible than reality might prove if tested. Soviet military planners gathered in concrete bunkers beneath Moscow's defense ministry complex, spreading reconnaissance photographs across steel tables while debating doctrinal changes that contradicted decades of armored warfare theory developed since tanks first rolled across European battlefields. The American cannon had invalidated fundamental assumptions about mass formation tactics, forcing theorists to reconsider whether numerical superiority retained meaning when individual vehicles could be destroyed faster than crews could react to incoming fire. Heated arguments erupted between old guard officers who'd commanded divisions through previous conflicts and younger analysts presenting computer models that predicted catastrophic losses under scenarios involving sustained air attack by the new weapon system. Cigarette smoke thickened the recycled air as debates stretched. Past midnight, colonels drawing tactical diagrams, while generals questioned whether their entire strategic posture required reconstruction around threats that couldn't be answered through conventional defensive measures. Some advocated for wider vehicle spacing that would sacrifice concentration of force. Others demanded accelerated armor, development programs that budget realities made impossible to implement across thousands of existing tanks. The discussions revealed cracks in Soviet military confidence that party officials preferred remained hidden from Western intelligence services, already probing for exactly such weaknesses. Solutions emerged slowly, compromise positions that satisfied neither conservative nor progressive factions, but represented desperate attempts to counter capabilities that had fundamentally altered battlefield calculations. New tactical manuals filtered down through Soviet armored divisions with instructions that confused veterans accustomed to different operational philosophies, their pages filled with dispersion requirements and evasive patterns that reduced offensive punch, while theoretically improving survivability against aerial threats. Tank commanders conducted formations drills across Eastern European training grounds, spreading vehicles to intervals that felt dangerously exposed, testing communication systems stressed by distances. Never intended in original designs, crews practiced rapid direction changes and smoke deployment sequences. Defensive measures that acknowledged their primary role had shifted from offensive spearhead to potential target requiring constant vigilance against dangers arriving from above. The psychological toll registered in maintenance reports and readiness assessments, experienced tankers requesting transfers or developing stress symptoms that medical officers attributed to training intensity, but privately recognized as fear of weapons they'd never actually faced. Younger conscripts absorbed the anxiety from senior personnel, learning to associate their vehicles with vulnerability rather than protection, understanding that armor thickness meant nothing against munitions designed specifically to defeat such defenses. Soviet industrial complexes received priority orders for reactive armor upgrades and active protection research, engineers working triple shifts to develop countermeasures against attack profiles described in classified intelligence summaries that provided disturbing detail about penetration capabilities. Prototype systems emerged from design bureaus with promising specifications that consistently failed field testing. The fundamental physics of the American weapon's velocity and ammunition composition defeating each attempted solution. Frustration mounted among technical specialists who'd previously solved armor challenges through incremental improvements, now confronting problems that seemed to defy conventional engineering approaches. Factory representatives attended strategy sessions alongside military planners. Uncomfortable alliances between uniform and civilian sectors united by recognition that existing production capabilities couldn't manufacture safety from threats operating outside traditional parameters. Some proposals bordered on science fiction, desperation breeding wild innovations that budget committees rejected as impractical while offering no viable alternatives. The weapon had created an asymmetric challenge that Soviet industrial might struggle to answer, their quantitative advantages in production neutralized by qualitative deficiencies in protection. Warsaw Pact exercises incorporated new defensive doctrines with results that satisfied no one, simulation outcomes predicting unacceptable casualty rates even when theoretical countermeasures functioned perfectly under controlled conditions that bore little resemblance to actual combat chaos. Allied nation commanders expressed private concerns about tactics that sacrificed offensive capability for marginal survival improvements, questioning whether restructured formations could achieve strategic objectives if conventional conflict erupted across Central Europe. The American weapon had accomplished its purpose without firing a single combat round against Soviet forces, forcing doctrinal revolution that consumed resources and morale while spreading doubt throughout military hierarchies previously confident in their armored supremacy. The first confirmed battlefield encounter occurred in a desert theater thousands of miles from European scenarios war planners had imagined, where Soviet-manufactured tanks advanced through swirling sand under commanders confident their export models retained enough capability to dominate regional conflicts despite being older variants sold to client states. American aircraft appeared as distant specks against crystalline sky, approaching at altitudes that seemed unthreatening to crews trained to fear high-level bombers rather than low-flying attack platforms designed for entirely different combat philosophies. The distinctive sound arrived seconds before visual confirmation, a mechanical roar, unlike anything in conventional aerial warfare doctrine, filling radio headsets with noise that drowned coordination attempts while tank commanders squinted through periscopes trying to identify threats moving with unexpected speed toward their formations. Then the impacts began, transformations happening so rapidly that observers struggled to process sequential events as explosive rounds found targets with precision that suggested guidance systems, though the weapon relied purely on volume and ballistics. Armored vehicles that had dominated previous engagements simply disintegrated under sustained fire, turrets separating from chassis, while internal ammunition cooked off in secondary explosions that sent shockwaves. Across hardpan terrain, survivors abandoned disabled machines running from metal coffins that offered no protection against ammunition designed specifically to defeat such barriers. The engagement lasted minutes, but generated reports that circulated through military intelligence networks for months afterward, each analysis confirming capabilities that transformed theoretical concerns into documented reality. Soviet advisors embedded with Allied forces transmitted urgent assessments back to Moscow command centers, their encrypted communications betraying barely controlled alarm at witnessing destruction that exceeded worst-case projections developed during strategic planning exercises. Tank crews who'd received training in Soviet facilities described helplessness watching comrades die inside vehicles presumed safe, their accounts emphasizing speed of destruction that prevented effective response or tactical adaptation during actual combat. Detailed damage analysis revealed penetration characteristics matching classified intelligence. Reports depleted uranium rounds having punched through armor plates at angles that conventional projectiles couldn't achieve, validating fears that had driven doctrinal revisions across Warsaw-packed armored divisions. Photographs circulated through restricted channels showed aftermath scenes that military sensors worked to suppress twisted metal, and burn patterns telling technical stories that defense analysts found deeply disturbing. The weapon had transitioned from theoretical threat to proven capability, battlefield validation erasing any remaining hope that American claims represented exaggeration or propaganda rather than genuine tactical revolution. Additional encounters in various regional conflicts produced consistent results that eliminated statistical anomaly explanations, each engagement demonstrating reliability that distinguished the weapon system from experimental technologies that failed under operational stress. Proxy forces equipped with Soviet armor began requesting different equipment or air support guarantees before committing to operations where the American aircraft might appear, their reluctance spreading through military formations as survival instinct overwhelmed ideological commitment or contractual obligations. Intelligence services documented psychological impact extending beyond physical casualties, tank crews developing acute stress responses, and refusing combat assignments after witnessing what the cannon could accomplish against hardened targets. The weapon's reputation grew with each confirmed engagement, battlefield mythology merging with technical reality to create deterrent effects that strategic planners hadn't anticipated during original development programs. Moscow's military Leadership convened emergency assessments reviewing accumulated combat data that painted undeniable pictures of vulnerability, their private discussions acknowledging that conventional armored warfare had been fundamentally altered by innovation they couldn't rapidly counter or replicate. The cannon had proven itself not through massive campaigns, but through scattered engagements that collectively demonstrated dominance, each battlefield validation reinforcing Western technological advantage while exposing Soviet doctrinal inadequacies that decades of military investment hadn't prepared them to address. The cannon's legacy solidified not through diplomatic treaties or technological obsolescence, but through permanent alteration of military calculus that survived the Cold War's conclusion and persisted into conflicts where Soviet-designed armor continued appearing on battlefields decades after the Iron Curtain's collapse. Defense academies on both sides of the former divide incorporated the weapons system into curriculum as case study demonstrating how single innovations could invalidate entire strategic doctrines. Lecturers using declassified footage to illustrate moments when technological superiority trumped numerical advantage in ways that reshaped procurement priorities across multiple nations. The psychological dimension proved equally enduring. Veterans from various conflicts sharing stories that transformed the aircraft and its cannon into legend, exceeding mere specifications. Their accounts describing not just destruction, but helplessness against weapons that seemed to operate outside conventional warfare parameters. Soviet military officials who'd spent careers developing countermeasures found themselves in retirement privately admitting the cannon represented breakthrough they'd never adequately answered. Their journals and memoirs containing passages describing frustration at watching armored doctrine rendered obsolete by American ingenuity that combined existing technologies in unexpected configuration. Museum displays now showcase artifacts from both sides of this technological competition. Russian tank armor bearing distinctive penetration patterns positioned near cutaway models of the cannon that created such damage, silent testimony to engineering victories that determined outcomes beyond individual battles. The term certain Soviet planners used in classified communications, translated roughly as sorcery or witchcraft, their language choice revealing cognitive dissonance between rational military analysis and emotional response to weapon effects that seemed to defy protective measures. Armor specialists had considered adequate against conventional threats. Technical committees tasked with developing countermeasures produced reports acknowledging no reliable defense existed within acceptable weight and cost parameters, their conclusions forcing acceptance that American aircraft carrying these cannons would dominate any armored engagement until entirely new protective paradigms emerged from research still in theoretical stages. Training facilities modified exercises to emphasize dispersion and concealment rather than frontal engagement. Tactical shifts representing implicit admission that direct confrontation with the weapon system meant certain destruction regardless of crew skill or vehicle capability. Intelligence assessments circulated through Warsaw Pact commands quantifying the imbalance, calculations showing how few American aircraft could neutralize tank battalions that previously required massive defensive commitments to contain, mathematics that haunted strategic planners contemplating European scenarios where such capabilities would multiply across numerous squadrons. The weapon fundamentally altered armored warfare's cost-benefit analysis, making expensive tank formations vulnerable to relatively affordable aircraft in ways that reversed Cold War assumptions about mechanized superiority and forced comprehensive doctrinal reconsideration across multiple military establishments. Proxy conflicts continued, providing validation throughout subsequent decades. Each engagement where Soviet-designed armor faced the cannon reinforcing lessons learned during initial encounters that had sent urgent warnings through Moscow's military hierarchy. Defense contractors worldwide studied the system's success, attempting replications that never quite achieved the original's devastating effectiveness. Their failures, highlighting how the weapon represented perfect convergence of design philosophy and engineering execution rather than easily copied technology. Modern warfare still bears imprints of innovations this Cold War program introduced, tactical approaches and vehicle designs, incorporating lessons from battles where the cannon demonstrated capabilities that permanently changed how militaries conceptualize air-ground combat dynamics. The balance of power shifted not through negotiations, but through battlefield demonstrations that made numerical advantages irrelevant against technological superiority, the cannon's existence forcing strategic recalculations that acknowledged American innovation had created tactical situations where Soviet armor concentrations represented targets rather than threats. Historians examining declassified documents discovered the extent to which this single weapon system influenced military planning on both sides, its shadow extending across procurement decisions and force deployments that shaped Cold War's final decades, when conventional conflict remained perpetually possible, yet never materialized, partly because weapons like this made outcomes increasingly predictable in ways that discouraged escalation among rational actors recognizing futility. What other Cold War weapons fundamentally changed military strategy forever? Subscribe to explore more untold stories from history's most tense era.